For our first objective, you will be able to determine the intervals on which a function is increasing or decreasing, and you'll be able to do it by using the first derivative. If you take a look at the image here, you can see a family obviously having a fantastic time riding a roller coaster, and this roller coaster has just hit some sort of peak coming down on the downward slope where that thing is obviously decreasing. So as we've seen, as we've discovered, tangent lines at each point travels in the same direction as the graph of f of x. As a matter of fact, whenever we kind of informally defined tangent line ages ago, before we even had limits, that's what we had to say, because a tangent line is only supposed to hit a curve once, but sometimes it dips down and hits it more than once. So we had to say, oh yeah, but it's the one that touches the curve over some sort of interval only one time and it goes in the same direction. It's the same thing as the slope. So if your tangent line's going upwards, then so is your original function. If your tangent line, which is measured by the derivative, is positive, then your function must be increasing over whatever interval that we're talking about. Now, this is not the definition of where your function is increasing. As a matter of fact, increasing and decreasing, those are algebraic definitions. So let's take a look at those and see if we can make sense of where a function is increasing or decreasing without calculus. So let's let f of x be defined by the graphed function, very strange function, has a little constant portion right here in the middle for whatever reason. Intuitively, what does it mean for f of x to be increasing on the interval from 0 to 3? Well, increasing, obviously, it just means that it's going upwards. From left to right, it's going upwards. If it's constant, that means it's staying the same. It's nice, flat, and horizontal. And then finally, it's decreasing from 5 to 8. That means that it must be going downwards. Okay, those are intuitive definitions. Now let's talk about some sort of formal definition here. So it's asking us to find f of 1 and f of 2 on the graph. So it's a little bit easier for me to just write on the graph right here. Let's see. F of 1. F of 1, follow this thing straight up and then come over. It looks like f of 1 is equal to 2. Okay, and then we want to find f of 2. Come straight up. Bam. Looks like that might be 4, perhaps. Maybe it's a little bit bigger than 4. This line right here does not look horizontal. Okay, so we're going to say it's approximately equal to 4, so f of 2 is equal to 4. And so what I want you to notice about this, since it is increasing on this interval, the x value of 1 is less than this x value of 2. And if it's increasing, then that means that the y value at 1 must be smaller than the y value here at 2, right? It's another way of saying is as the x's are getting bigger, the y's are also getting bigger. Okay, so that's what it means for it to be increasing. We'll write something down algebraically in just a minute, but let's take a look at decreasing. So we're going to do the same kind of thing on f of 6 and f of 7. So f of 6, follow this up to the graph, and it looks like it's hitting about 5. Maybe that's where the other one should have been hitting. I don't even know. So f of 6 looks like it's about 5. And then let's do the same thing here at 7. Looks like it might be hitting over there at 2-ish. F of 7 is about 2. Okay, so this time, decreasing. It's going downwards, right? And we notice that obviously the 6, that x value is less than this 7 x value, but the y value is bigger for 6 than it is for 7. Another way of saying this is as the x's get bigger on your interval, your y values are getting smaller. That's what's happening on an interval over which your function is decreasing. Okay, let's fast forward here. Then here are the formal algebraic definitions of when your function is increasing and decreasing. So the first part here is a function f is increasing on an interval if for any two numbers, x sub 1 and x sub 2 in the interval, x sub 1 less than x sub 2 implies that f of x sub 1 is less than f of x sub 2. So it just means your graph moving from left to right, it's going upwards. It means that as your x's get bigger, so do your y's get bigger. Okay, so there's where our function is increasing. And then we can see right here that Our function is just straight up constant there. It's horizontal. That means as x's get bigger, the y's do a whole bunch of nothing. Okay, not a little definition for that one. However, for decreasing, a function f is decreasing on an interval if for any two numbers x sub 1 and x sub 2 in the interval, x sub 1 being less than x sub 2 implies f of x sub 1 is actually bigger than f of x sub 2. It means that the graph of your function is going downwards as you move from left to right. It also means that as the x's get bigger, moving from left to right, then your y values are getting smaller. Right? So here are the algebraic definitions for increasing and decreasing. And notice that at no point does it ever mention the first derivative or the second derivative or anything like that. Those are what we're going to use in order to determine where the function might be increasing or decreasing. But the definition comes from these algebra definitions here. Okay, so we're going to do a little investigation. And in this investigation, what we're trying to do is to connect that derivative, that first derivative, specifically to where our function is increasing or decreasing. So you should find a handout that has this investigation on it. It has three different functions here. I'd like for you to graph that function. You can use a graphing calculator to help you graph it. And you're going to find mins and maxes. Again, you're just using the calculator to help you find those min and maxes. You also want to find critical values, as you can see right here. Critical values, derivative is 0, undefined. Where's it increasing? Where's your derivative positive? Where's f of x decreasing? Where is f prime negative? And so on. So you will make those connections in order to draw these conjectures down at the bottom.